Today we're going to have a look at a few combinations. The first one we're going to have a look at is how can we mix up the product and the chain rule. So in this case, you might look at it and you go, oh, this is product rule. We've got one function here and one function here. Should be nice and easy, no trouble whatsoever. But we'll see that in order to use the product rule, we need to know both u dash and v dash. V dash is fine because v dash is just 1. But in order to differentiate u, we're going to have to work a little bit harder. So if u is equal to the square root of 3x minus 1, how do I take the derivative of that? Well, first of all, I better write this as 3x minus 1 all to the power of half. Now, I can't actually take the derivative of this without using the chain rule, right? This is a chain rule question. If I asked you to derive u right now, you'd go, well, I need to do a u substitution. Can't do a u substitution. U has already been used. So I'm going to use a w substitution. W to the half. Alrighty, where w is equal to 3x minus 1. Alrighty, so now I'm just going to do the usual thing. So this is du dw, which is going to be a half w to the minus a half. And dw dx is going to be equal to 3. And by the chain rule, du dx will be du dw times dw dx, which I've already worked out both of these. So we get a half w to the minus a half times 3. W, though, is not an x. So I might want to substitute back in what w is representing, which is 3x minus 1. So we get equals 3 on 2, and then in brackets 3x minus 1 to the negative a half, which I would probably better write as 3 on the square root of 3x minus 1. Alrighty, so all of that was to just deal with bloody u. Haven't even looked at v yet because v is nice and easy. So at this point I've worked out u and du dx. Now I need to work out v and dv dx. So let's go and deal with v. So v is equal to x plus 5 and dv dx is equal to 1. Okay, so one of these was easier than the other, but that's fine. So we found out u, we found out du dx, we found out v, we found out dv dx. Now we can use the product rule. So dy dx is going to be equal to derivative of the first times second, du dx v plus dv dx u. Alrighty, so there's chain rule in full flow. Sorry, just rewritten the product rule properly. Alrighty, and now I can just do some substitution. So in this case, u is equal to root 3x minus 1. dv dx is 1. V is x plus 5. And dv dx is 3 on 2 root 3x minus 1. Alrighty, I've decided to put down a demarcation line. Alrighty, so now I've got a bunch of algebra to do. So the first thing is I'm going to expand out these first brackets here. So if I expand out, well, I'm timesing things by 1. So I get root 3x minus 1. Very exciting. And these brackets are a little bit more interesting. However, when multiplying fractions, you just go top times top, bottom times bottom. This is a bottom of 1, so the bottom's not going to change. So we're going to get 3x plus 5, all on the denominator, same as before, 2 root 3x minus 1. Alrighty. Now, often it might be useful to write this as one fraction instead of as two. And so that's what I'm going to try and do now. Problem is, this has a denominator of 2 root 3x minus 1, and this currently has a denominator of 1. So I need to change the denominator. So I'm going to multiply top and bottom of the left fraction, which is not quite a fraction yet, by 2 root 3x minus 1. And in this way, I'm not actually changing it. And the left-hand side, I might as well just expand out these brackets. So I'm going to get 3x plus 15, and the denominator is going to stay the same. Alrighty, now if we have a look, this is actually quite a nice thing to look at, because these two things are looking very similar. In fact, they are exactly the same, and because of that, they are both to the power of a half plus a half is a whole, and so I get to the power of 1, or I can just write it like so, all over 2 root 3x minus 1. And the 2 just moves itself to the front by normal multiplication. However, now I've got a 2 on the top and the bottom, so I'm just going to cancel out those. And now I'm going to... Oh, actually, I'm not going to cancel those out, because that would be terrible. If I cancel the 2 from the bottom, then I wouldn't be able to add the fractions together. So I'm going to leave the 2 there for fraction purposes. And now I've got 3x plus 15 all over 2 root 3x minus 1. They have the same denominator, so I can add the tops. So I get 2 3x minus 1 plus 3x plus 15 all over 2 root 3x minus 1. Alrighty, so now I've got a single algebraic fraction instead of 2, and now I can expand those left brackets, and if I were to expand those left brackets, I would get 6x minus 2. And now I can collect like terms, and I get 9x plus 13, all on 2 root 3x minus 1. Alrighty, so that is an example of a more complicated product rule question, where you're going to need to use some chain rule. See you in the next one, where we do the same with the quotient rule. See you there. Bye-bye.